Welcome to Section 4 of Learn Go in 3 hours. In this section, we will explore 3 related concepts: how to organize your code, how to use code from other people, and how to organize your data by creating data types that contain other data types. We start by introducing packages, explaining how to use them by looking at the standard library, and creating packages of our own. We then start using the type-safe containers built into Go, slices and maps. Finally, we introduce the struct, which is a type that contains other types. For our first video in Section 4, we're looking at packages and imports. Packages are not a Go invention. Most modern programming languages have a similar concept. But like other common language features, Go adds a slightly different take on the idea. And we've already seen package declarations and import statements in the code we've written in previous sections, but all our code was located in a package called main. Well, that's the starting point for a Go program. We don't usually put all of our code in a single package. Go programs are usually broken into multiple packages, each one focused on one area of functionality. Each package contains a group of related functions and data types, and each directory in the source code repository for a Go program is associated with a unique package. When you share your code with other people, you share it via packages. The way to specify the packages that your code depends on is by importing. If a package is not imported, you cannot access the code within the package. This is different from Java, where importing a package simply means you can refer to the code within it by a shorter name. Both Java and Python allow you to import single items out of a package. Go doesn't allow that. Instead, importing a package gives you access to everything in the package. To import a package, you use the keyword import, followed by the path to the location of the package either within the standard library or within your Go path. The path to the package is a string literal enclosed in quotes. If you have more than one package to import, you can either repeat the import keyword over and over for each import, or write import, followed by a left parenthesis, list each package on its own line, and when you're done, end with a right parenthesis. Once a package is imported, you refer to the functions, types, and variables in the package by using the name of the package, a dot, and the name of the item. That's why we typed func.println whenever we use the println function in the funct package. Packages fall into 3 general categories: the packages you create, the third-party packages that other people create, and the packages in the standard library. We'll discuss the first 2 categories in later videos, but let's spend some time looking at a couple of the packages included in the standard library, along with some sample code that demonstrates their functionality. So as I mentioned back in Section 1, Go Standard Library contains many tools designed to solve problems that developers face today. We've seen a few already, and we are covering more here just to give you a taste of what's available. The first package we are covering is the strings package. In some languages, the strings type has methods defined on it that are used to manipulate strings. Go doesn't put methods on its built-in types. Instead, it has packages in the standard library to provide that functionality. Whenever you want to do string manipulation, the strings package is the first place you should look. It has functions that compare strings, see if strings contain other strings, see if strings contain runes, see if strings are identical ignoring case, split strings, trim strings, or convert strings to uppercase or lowercase, and there's many other functions as well. There's also a useful function called map that allows you to replace one rune in a string with another according to rules defined in a function that you pass in. Let's take a look at how that works. So we're going to switch to Visual Studio Code and create a new project. We'll create a new project in a directory. Go, source, github.com, your username, and create a new folder called Learn Packages. And open that up. Inside of Learn Packages, create a file called learnpackages.go. And here's a source code for this first program. So this program implements one of the simplest and worst encryption systems, ROT13. It simply rotates every letter in the English alphabet by 13 characters. The advantage of ROT13 is that the same function is used for both encryption and decryption. If you run the algorithm over text that has already been encrypted with ROT13, you get back your original text. On lines 3 through 6, we see our compound import statement, pulling in 2 packages, funct and strings. Our encryption algorithm is implemented on lines 8 through 16. On lines 20 and 22, we call the strings.map function, passing in our encryption algorithm and the source string. And on lines 21 and 23, we see our familiar calls to funct.println. When we run this program, we see our encrypted text on one line and the decrypted text on the next. So it might be surprising, but there are no functions for working with UTF-8 in the strings package. Those functions are found in a different package, the Unicode/UTF-8 package. The most useful function in there is rune count in string, which tells you how many runes are present in a string. Remember, when we first learned about strings in the fourth video in section 2, we saw that the built-in len function only returned the number of bytes in a string. If you need to know the number of actual characters in a string, use utf8.runeCountinString. And here's what that looks like. On lines 3 through 6, we have our import statement, this time with funct and unicode/utf8. Notice that unicode/utf8 is a path to the location of the UTF package in the standard library. On line 12, we call the function runeCountinString in the UTF-8 package by using just the UTF-8 part of that path. When we run this code, we see the difference between the output from the built-in len function and the UTF-8 runeCountinString function. Len returns 9, because that's the number of bytes in the string, while runeCountinString returns 3, because that is the number of characters in the string. The time package provides functions for specifying times, comparing them, and formatting them. The function now returns the current time as a value of type time.time. And if you want to get the time in Unix format, you call the Unix nano method on the time.time value. We'll talk a lot more about methods in Go in section 5. The next package we're going to look at is the math package. The math package contains functions to calculate trigonometric functions, exponents, and logs, and also to find the min or max of two numbers. Now, all of these functions are written for numbers of type float64. This means that if you want to use them with integer variables, you need to convert your int variables to float64 before passing them in, and convert the output to an int afterwards. If you need a pseudo-random number generator, you can find that in the math/rand package. The easiest way to use it is to call the rand.seed function, passing in a value to initialize the pseudo-random number generator. If you pass the same value, you will get the same sequence of numbers every time. If you want random values, pass in the current time using time.now.unixnano. Once the random number generator is seeded, you can call the various functions in the math./rand to get your random numbers. The most useful function is probably int_n, which returns a random number that is greater than or equal to 0 and less than the int passed to the function. So let's write a program that uses the time, math, and math/rand packages. So here's one that seeds the random number generator, generates two random numbers, and then compares them to see which one is bigger. On lines 3 through 8, we import the packages we need. Notice that we import both math and math/rand. Even though you might think that the math/rand package is inside the math package, you have to import both explicitly if you are using both. On line 11, we initialize the random seed by calling rand.seed with the value returned from time.now.unixnano. On lines 12 and 13, we call rand.int_n to pick two random numbers that are both greater than or equal to 0, and less than 10. On line 14, we call math.max, converting our ints to float64 when they are passed in, and converting the return value back to an int from a float64. Finally, on lines 15 through 17, we print out our numbers and which number was bigger. And every time you run this program, you should get different results. So there are many more packages in the standard library, providing, among other things, ways to process images, create text and HTML templates, encode and decode text in several formats, send and receive data over a network, and interact with the operating system. In future sections, we will introduce other packages in the standard library. If you want to learn more, go to https://golang.org/pkg to see all the packages that Go ships with. So in this video, we've learned more about packages in Go, importing packages from the standard library, and taking a very quick tour of some of the features that are available in the standard library.